Okay, so this is the last video that I'll make for this week. I will put up some other resources for you on Canvas. And let me urge you to do some practicing. This is kind of like a math class where an instructor will go through a various math problem. It'll look so easy when the instructor does it that sometimes you think, I don't have to study that. I got that. Well, and then you see something on a quiz or a test and you go, I can't even get started. At least that has happened to me in the past with maybe math. But anyway, I wanted to show you a dihybrid cross. So I am using this setup. In pea plants, tall is completely dominant over short, and green pods are completely dominant over yellow pods. In our example, both the male and female are tall and have green pods, and they're heterozygous for each of those traits. There's my phone ringing. I'm not going to answer it. It'll stop in a minute. So, big T for tall, little t for short. Big G, green, little g, yellow. So I said they were both heterozygous for both traits. So, big T, little g times big T, big G, little g. Now this isn't as simple as just taking two T's and separating them. We have to look at the combos of the T's and the G's for the potential gametes. So, if I take the big T first and put it with the first G, that's big T, big G. Then I take this same big T and combine it with the little g. So there are two of my gametes. Then I take the little t and put it with the big G, and the little t with the little g. Alright? So those are all the possible combinations of the T's and the G's. Same thing will happen over here, but let's do it a little differently. So big T, big G, big T, little t, big G, and little t, little g. In some ways, this is one of the hardest parts, or the most challenging. I don't like to use the word hard, or like to use hardest, but the most challenging parts of preparing a dihybrid cross is determining the gametes. Now this is a 16 square instead of 4. And instead of putting one letter, you put each of these gametes. Big G, big T, big G. Big T, little g. Little t, big G. And little t, little g. Same down this side. So this is, let's say, the male. And this can be our female. So, again, big T, big G, big T, little t, big G, and little t, little g. So when we combine these, we're going to have 4 letters in here because we're representing 2 traits. They're dihybrids, so we need 2 of each letter. So, keep the letters together. Big T, big G, big G. Okay? Let's look at this one. Big T, big G, little g. Then we have big T, little t, and big G, and big G. You see what I'm doing? And finally, for this row, we complete it with big T, big G, little g. We come down here, we're going to cross these with these. Big T, big G, little g. Big T, little g, little g. Big T, big G, little g. Big T, little g, little g. Down to this one. Big T, big G, big G. Big T, big G, little g. Little t, big G, big G. Little t, big G, and little g. Do you see what I'm doing? It's a pattern. I just am following, I'm putting the gametes together. So now this one and this one. Big T, big G, little g. These two. Big T, G, little g. These two. Little t, big G, little g. And these two. All lowercase letters. When you look at this, you see multiple genotypes. And I personally am not interested in the genotypes. What I'm interested in are the phenotypes, and I do this in kind of a column or linear. So phenotypic ratio. That's all I'm interested in, not the genotypic. And what I'm interested in then are all the ones that are tall. So any plant that is tall has at least one big G or one big T, because this is complete dominance. So it doesn't matter what's here. It can be a big T or a little t. Anyone that has a green pea pod has a big G. It can have two big G's or it can have a little g there. So these are tall and green. All right? Then, tall and yellow. Whoops, I don't know why I'm putting Y's. To be yellow, they have to have the two little g's. Now I go to the short ones. So, two little t's, but I want tall and green. So it's, not tall and green, a green, so it can be a big G or a little g there. So short and green. And then finally, the one that is homozygous recessive for both traits, which means it's short and yellow. Okay. Then it's just simply counting these. So here we go. I'm going to start with the tall green. So any of them that have a big T and a big G. And I like to mark through them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9 that are tall with green pods. Then, how many are tall with yellow pods? 1, 2, 3. How many are short with green pods? 1, 2, 3. There's one left, down here. Now there are 16 squares here. A good way to make sure that you have the correct number is to add these. 12, 15, 16. So yes, indeed, I have 16 here. The thing is, I knew the answer before. I knew that if I have complete dominance for both traits, and I had two parents that are heterozygous for both of these traits or characters, that my phenotypic ratio would be 9 dominant, 3 dominant recessive, 3 recessive dominant, and 1 recessive as far as the phenotypes. Because that's always the answer, is 9 to 3 to 3 to 1. But that's not the one I would ask you to do. So there are different answers if you used different. So let's do something different. Just real quick. So we will have gone through 2 of these. Probably be faster just to redraw it, huh? Okay, so let's do one where the male is tall, homozygous, and yellow, and the female is tall, heterozygous, and green, heterozygous. Our answer is not going to be 9 to 3 to 3 to 1. So let's look at these gametes now. So we have big T, little g, and we have big T, big G, little g. This one, we take this big T, put it with this G, we get big T, little g. We take this one, put it with this one, we still get big T, little g. We take this one and put it with this one, and we still get big T, little g. Here, big T, little g. You could actually do this with just changing this to the male and putting this one time. But we're going to do it with the 16 squares. This one is like our first appearance. Big T, big G, big T, little g. Little t, big G, and little t, little g. Now, what happens? Big T, big G, little g, big T, little g, big T, big G, little g, big T, little g, little g. Okay, so we just do that again. Notice they're the same going down. If they're not, I'm making an error. All right, well, let's look what we have this time. Tall and green. 1, 2, 3, 4, 5, 6, 7, 8. How many tall and yellow? 1, 2, 3, 4, 5, 6, 7, 8. 8 and 8 is 16. And there are zeros for those two. Okay, so it's not always 9 to 3 to 3 to 1, but it equals 16. So that should be the end of my PowerPoints, or not PowerPoints, my lectures for you. This is a board lecture. And I wanted to remind you that on some of the assignments, like in fact the quiz